Hello everyone. Let's continue with our discussions on Newton's laws. This time, let's study Newton's third law. Newton's third law states that when a body exerts a force on another body, the latter also exerts a force on the first. That is, forces always occur in pairs. Take note that we are dealing in here a two-body system. Take note that we have in here the first body doing the action on another body, the second body. So if this is the action, then the other body exerts the reaction force. So forces always come in pairs. So there must be an action and there is always equal. So this equal refers to the magnitude of the force. And opposite reaction, it refers to the direction. The direction which is exactly opposite. Let's try this illustration. Sample, we have a box M resting on top of the table. So let's label our box as body A and then the tabletop our body B. So in here, our body A will exert a force on our body B with the force Fa. And also our body B will exert a force equal and opposite in direction to the force Fa. So this is Fb. So the magnitude of these two forces should be equal, but then their direction is opposite. If this is the Fa, this is equal to the negative of our Fb, or the force exerted by the body B. So take note that both action and reaction are exactly equal. One cannot be slightly less or more than the other. So this is very easy to accept for object not in motion or at rest. But how about objects in motion? So let's have another illustration. Take, for instance, a man pushing a boy forward with a force Fm. So while they are both moving, it appears that the boy, being the weaker of the two, pushes back against the man with a smaller force. But according to the third law, the boy pushes exactly as much on the man as the man pushes against the boy, no matter how strong the man in comparison to the little boy. The force exerted by the man is still equal to the force exerted by the boy, but in exactly opposite direction. This is third law. Indeed, forces come in pairs, equal and opposite. Let me ask you this question. If action and reaction always come in pairs, which means there is equal in magnitude and opposite in direction, then how could there be an unbalanced force? Why, if net is not always equal to zero? If forces occur in pairs and then always opposite and equal in magnitude. So what do you think? So the forces in a pair act on different objects. Take note, in our third law, there is a two-body system. The action and the reaction happens between two different bodies. Whereas in first law and second law, we focused on the unbalanced forces acting on a one-body system. All the forces acting on the body we sum up, but not the reaction of that one body, since the two paired action-reaction forces act on different objects, thus the two forces do not cancel. So try to think about the situation. The gravity is pulling you down on your seat. This is the Fg force. But your seat is pushing you up against you with equal force. So this is why you are not moving. So there is a balanced force acting on you, gravity pulling you down, and your seat pushing you up. The question, is this the third law that we are referring to? Is this the action and reaction pair of forces that is equal in magnitude but opposite in direction? I don't think so. Let's analyze. Take note that the force of gravity is not your reaction force, right? And the force exerted by the surface is not your force. So if you are the one body system, this Fs, and Fg are external forces. So these are not the action and reaction pair of forces, which is referred to by the third law. The Fs and Fg are the forces acting on you. They are not interacting with each other. Then, what is the internal forces? The internal forces are the forces you exert in response to the external force exerting on you. So if the force of gravity is pulling you down, you are also pulling up with the same magnitude of Fg. And if the surface is pushing you up, you are also pushing down. So your reaction are considered the internal forces if you are the single body system. So identifying correctly internal and external forces is very important in writing the FBD, or the free body diagram, or FBD. So hint in writing a free body diagram: if mass is given, so there must be a force of gravity acting. So there is weight. Then if there is surface, you need to think that surface might have friction, because friction occurs between surfaces. So what's the direction of friction? It should be opposite to the motion. Aside from friction, there is the normal force N exerted by the surface, and this is always perpendicular to the surface in contact. And if there is string, rope, and the like, so this exerts a tensile force or tension in symbol T. If there is other force, example, exerted by the man in pushing or pulling, so let's just label this as F, or other forces. So let's label this as just F. Example. So consider this illustration. If we have this box sliding on an inclined plane, let's label the forces. So there is mass M. Of course, gravity will act on it. So we have now the weight force, weight. And then the weight should be always downward. And another, there is surface. So there must be friction. So label this as our friction F. And the normal force exerted by the surface. So this is always perpendicular to the surface. So since this is the surface, our normal force is in this direction. And there's a rope pulling the box down. So we can label this force as our tension. So this force T. But this is not yet a free body diagram, because a free body diagram only the sketch of the forces acting on the body or particular body. So our FBD will look like this. No more body, but then only the sketch of interacting forces with their common tail located at the origin. So what have you noticed? In determining the net force for our first and second law, we only use a one-body system and only consider or identify all the forces acting on the body. So not including the reaction force of that body. That's the focus in calculating the summation of forces. Either this is equal to 0 for first law, summation of forces equal to MA if it is second law. But then again, these are all external forces.